Okay. We might do the chair confirmation just based on this, but I will still explain yours. Okay. Okay. We'll go over discussion menu page 56. It's the week 4. We're doing stereochemistry. Now this is the 10th pair, which is the bottom pair of the question number 3. It's asking what's the relationship between these two? Are they enantiomer, diastereomer, identical, or meso? Okay. So if you actually take today's class, what's the lecture notes? 13? Okay, so your best, yeah, it's not the best because I did not write it, okay? You should watch lecture video, okay? Notes, okay, it's on note 13, okay? I emphasize that in the class. No matter who asks you why they're a pair of enantiomer or diastereomer, it's the back page, the summarize, okay? The mirror image or image superimposable with each other. No matter who asks you, that's the case, okay? But in really practical ways, okay, we assign R and S on both stereocenter. I'm talking about not only this one, okay? Most of the time you assign R and S of the stereocenters and to see, okay, if only if all of their stereocenters are opposite to each other, only if all stereocenter opposite to each other, they're a pair of enantiomers, as long as one of them is the same. As long as not all are opposites, they're a pair of diastereomers. Okay, it works 99% of the time. Okay, the only difference, okay, 1% is part of here. When you start to see their symmetrical plane. When you start to see their symmetrical plane, okay? And then there are 2 things you should do for symmetrical plane, okay? In this case, I'll show 2 different ways, okay? Well, okay, I will need my model, but I don't. Okay, I'll show the, okay, we'll do one way first, okay? When you see 6-member ring, what I write on the notes, do the chair confirmation of it, right? Okay, let's do the chair confirmation. Okay, so BR. Are we cool with that? Okay. How about this one? Oh, sorry, one of them is not correct. This one, equatorial, okay? Because they're both pointing up, okay? Yeah. Are people going to say, they're symmetrical plane. Look at the real structure. They're chair. Do you still think they have mirror plane on chair? Okay, but we can do ring flip, right? Okay, if we do ring flip, okay. Yeah. Okay. When we do ring flip of this one, this become, just write smaller. Okay, BR. And this one become equatorial. Are we good with this one?
Are they? Is that why they're meso?
So, it's kind of like you can. Are you good with they're not? I would actually treat this one as identical. Actually, okay. No, they're not identical because they need to be. Well, I actually want to treat this one as identical. I think it's not meso. Is the answer key identical?
The answer key was meso.
The answer here is meso. Okay. I will treat. Okay, if you look at this, they like a symmetrical plane. The points I want to make here, from me, they're identical for 2 reasons. One, whenever it's a 6-member ring, as I teach in the class, you should view them as a chair because the real structure is a chair. And the symmetrical plane that you think in a chair actually does not exist. Are we good? Okay, the second thing is if you do the chair, if you do the ring flip, look at this. If you keep rotating, there's 2, just like if you view from the other side, it's the same thing as that one. So in my perspective, these are a pair of identical. Bec-
you saying that those two are mirror images of each other?
they're not mirror image.
Okay.
They're identical. They're the same compound. Okay. Yes.
So what if we wanted to like assign R and S and then do it like that? Like, could that be a way of solving this?
This could be solving this, but did you still remember? Okay, what would you solve this would be all of their stereocenter is going to be opposite.
Right.
So when I say all of, okay, or 99%, okay, of that word, when you assign R and S, this become, okay, if R become S, R become S. I just randomly say, I don't know, okay. It's not going to be diastereomer because it's like a diastereomer will have the same. Only if all of them they're opposites, then you should start to think, is that meso? Yeah.
That's what I was confused about because for both of them, they're both R and S in the same positions.
Yeah, that's I got
They're
the
not
same.
opposite to each other.
Yeah, that's why I asked that. 'Cause then I
That's
thought they were the same.
I think this one, okay, I will treat them as identical though because of that, and they labeled RS wrong, kind of. It's not they labeled RS wrong. It's kind of like there's another way of doing this, but after we're done with the chair. Are we good with the chair?
Yeah.
Okay. If it's a 6 memory, I always recommend you to do the chair conformation. There looks like a symmetrical plane, but it is not. Okay, are we good? It's in the real world, it's like here. How is that supposed to be symmetrical, right? The real world is like the line I just drew separates. Okay, they are not mirror. Are we good? Are we good? Are we good? Are we good? Okay. I'll pose it here.